Okay, today we are going to start chapter 8, which is on hypothesis testing. This is another form of inference that is commonly used in statistics. All right, here we have the definition of hypothesis testing. Hypothesis testing is the use of statistics to determine the probability that a given hypothesis is true. So we're taking a hypothesis about the population, collecting a sample, and seeing if that sample allows us to believe in what we thought about the population or if it has evidence against that hypothesis. So that probability is used to determine which hypothesis is believable. All right, here's a scenario that we're going to use to just demonstrate the idea behind a hypothesis test. We have the question, do FCPS schools do better than the rest of the nation on the SAT? In 2019, the national average for the SAT was 1060 with a standard deviation of 195. If we do a cluster sampling of high schools in Frederick County and compare them to the rest of the nation, can we answer the question above? All right, so we have 3 schools here, Frederick High, Urbana High, and Oakdale High. And we're going to see just how common their score is if we compare it to the rest of the nation. I'm going to be using this normal curve applet to kind of demonstrate the distribution and also to find the probability of those values. All right, so our mu is 1060. That is our average SAT score nationally. So our population mean. Our population standard deviation was given as 195. So we see the adjustments to the normal curve. It's centered at around 1060. And again, as we move out standard deviations, it's approximately 200 to move out a standard deviation. All right, so our first school, Frederick High, they had an average SAT score of 1075. All right, so if we compare that to the national average, that is just slightly above the national average. So it's close to the mean of the nation. The probability corresponds with that. So our blue line here represents Frederick High. They are just slightly above the mean. And the probability that they would get something that high or higher is around 50% because it's approximately the mean. So that's going to happen pretty often. That's going to happen 50% of the time, or half the time we're going to get values of means that are at the national average. So do we think that they're higher than the national average? No, we think they're right pretty much at the national average. Now that value might vary a little bit, but that's just normal sampling variability. So not causing us to really think that Frederick High is above the national average. All right, let's look at Urbana. Urbana had an average SAT of 1255. So if we compare that to the mean, that's above the mean. And looking at that standard deviation, that's 1 standard deviation above the mean. All right, so taking a look at that probability is going to happen about 16% of the time. In other words, we're going to get a mean of 1255 or higher 15% or 16% of the time. So we can see that probability decreased. We're less likely to be that far from the mean just due to sampling variability. But 15% of the time, I don't know if we would really say, oh, we can be confident that Urbana is above the national average, because that's still going to happen 15% of the time. All right, let's look at Oakdale. Oakdale's average was 1480. If we compare that to the national average, it's like 2 standard deviations above the national average. That probability is much lower. That is only going to occur about 2% of the time, just due to normal sampling variability. Wow, Oakdale does really seem to be above the national average. as that probability decreases, as we move further to the right, we have increasingly strong evidence to say that that school is above the national average. So with only a probability of 2%, Oakdale, I think we are above the national average. Okay, we'll get into all of the nuts and bolts of how that works in the next lesson. Today, we're going to be concentrating on what's called the null and alternative hypothesis. The null hypothesis, or H sub 0, is the hypothesis or the belief that nothing is changing about the population parameter, the population value. In other words, we're talking about the mean today. So nothing's changing about the population mean. So for that last example, our null hypothesis, or H sub 0, would be that mu is equal to 1060. Or in other words, the national SAT score is 1060. All right, the alternative hypothesis, H sub A, is the hypothesis that if the population parameter, the mean, is changing, how is it changing? Is it increasing? Is it decreasing? Or is it just not equal to the value that we previously thought? So if we believe that Frederick County Public Schools are higher than the national average, my alternative would be that mu is greater than 1060. All right, we're going to do some more examples of writing the null and alternative hypotheses. In other words, the ho and the ha. So for this first example, it says a contractor claims that he can lower heating bills by using a special type of insulation in houses. If the average heating bill of the population is currently $78, what would the null and alternative hypotheses be to test his claim? Okay, so the null hypothesis says that nothing's changing about that population value, the population mean. So if nothing's changing about heating bills, we would expect the null hypothesis, H sub O, or the HO, to be mu, the population mean, is equal to that $78. Again, the population mean is not changing, so it's going to stay what it currently is, 78. If something is changing about that value, we want to know, well, how do we think it's changing? In the prompt, it gave us the keyword of he thinks that he can lower heating bills. So our alternative hypothesis is mu is less than 78. If something's changing about that heating bill cost, we expect that it's going to go down by using this special type of insulation. Okay, that's how we write our null and alternative hypothesis for this example. Let's go ahead and take a look at the next one together. Situation B says, a chemist invents an additive to increase the life of an automobile battery. If the mean lifetime of the automobile battery without the additive is 36 months, then what null and alternative hypothesis would she use to test her claim? All right, so if nothing's changing, we would expect the automobile batteries to last approximately 36 months. So that would be our null hypothesis, that mu, the population mean lifetime of automobile batteries, is 36 months. If something is changing, we look for that keyword. This one, it said, the chemist invents an additive to increase the life. Our alternative hypothesis, if that value is changing, we believe it's going to be greater than 36 months. The average automobile battery will last longer, greater than 36 months, with the additive. All right, let's take a look at one more example together. Situation C says, a medical researcher is interested in finding out whether a new medication will have any undesirable side effects. The researcher is particularly concerned with the pulse rates of the patients who take the medication. Will the pulse rate increase, decrease, or remain unchanged after a patient takes this medication? The average pulse rate is currently 72 beats per minute. All right, so Again, if nothing's changing, the null hypothesis rather, is the population mean is equal to 72. If something is changing, in other words, a patient takes this medication and their pulse rate is changed, we have to determine, does the medical researcher think that it's increasing, decreasing, or maybe we're not sure how it's going to be affected, so it would just be not equal to. And that's the case for this one. The alternative hypothesis is just mu does not equal 72. There was nothing in there that said the medical researcher thought that the pulse rates would increase or that the pulse rates would decrease. They're questioning what's going to happen to those pulse rates. So just to be sure we cover all of our bases, we're just going to pick the not equal to case. This is what you pick when there is no indicator word in the prompt that would indicate a greater or less than scenario. All right. This concludes our 3 examples. So guys, I'm going to ask you to take a look at the next 3. This is the you try. So take a minute, read through these 3 scenarios, pause the video, find your null and alternative hypothesis, and then unpause the video to see the answers. Okay, hopefully you had time to pause your video. The first example says, a researcher thinks that if expectant mothers use vitamin pills, the birth weights of babies will increase. The average birth weight of the population is 8.6 pounds. The null hypothesis is mu equals 8.6. And the alternative hypothesis is mu is greater than 8.6 because of that increase. B, an engineer hypothesizes that the mean number of defects can be decreased in a manufacturing process of compact discs by using robots instead of humans for certain tasks. The mean number of defective discs per 1,000 is 18. All right, so if nothing's changing about that value, mu is going to stay 18 per 1,000. If something is changing, we believe that it's going to decrease. So mu is less than 18 per 1,000. All right, final example. A psychologist feels that playing soft music during a test will change the results of the test. The psychologist is not sure whether the grades will be higher or lower. In the past, the mean of the scores was 73. All right, the null hypothesis is mean mu equals 73. The alternative hypothesis, we're not sure what's happening to that value, so we're just going to pick the not equal to case. We're not sure whether it's going up or down. All right. Guys, today we were focused on finding the null and alternative hypothesis. There are more steps to a hypothesis test. So after writing the hypotheses, we're going to be completing the whole statistical test. There's going to be more data in the prompt, so it's going to give us an average of the sample. It's going to give us a standard deviation, and we're going to use that data obtained from the sample to make a decision about whether the null should be rejected. So there's actually 6 steps to the hypothesis testing process that we're going to be using. We've completed step number 1 today. State the hypotheses. Be sure that those hypotheses are always in terms of the population parameter. In other words, for today, the population mean mu. We never want to use X bar or sample statistics when we write our null and alternative hypotheses. The remaining 5 steps we'll add on tomorrow. We're going to be finding the critical value, computing the test statistic, finding what's called the p-value, making the decision about the process, and summarizing the results.